Hi guys, welcome to the Pepcoding. In this video, we are going to solve design tic-tac-toe. So in this question, we have to design a tic-tac-toe where there are two players, 1 and 2, and we have some moves to that players, and there is n cross n board to play the tic-tac-toe. Now, now let's see the sample input and the output. Here, the sample input this three says that we have a board of n cross n, that is 3 cross 3. So this is 3 cross 3 board, and here these are the inputs, these are the moves of the players, where these two values 0 0, these are first is R, second is C, that is row and the column, and the player value where one first player and the second player is moving, whose move is this. Now like 0 0 1, here at 0 0 first player moved. Here we will check for the tic-tac-toe who is the winner. We need to check for the row, for the column, and for the diagonal. In this case there is no winner, so here 0 is returned. Now 0 2 0 2. So here the move is for the second player, so this will be for second player. For this we will also check row, column and diagonally, but there is no winner, so this means we have to return 0 again. Then the next move is at 2 2, the index 2 2 player 1, so 2 and 2 player 1. Still no one have win the tic-tac-toe, so 0 return. Next is 1 1 2 1 1, the second player. Here still there is no winner, return 0. Next is 1 0 2 1 0 2, that is second player. Still no one is the winner. I have missed this. At 2 0 there is 1, so at 2 0 there is player 1. Now at the last this is 2 1 2 1 2 1, the player is 1. So here we can see player 1 win the match of the tic-tac-toe, so we have written 1 here. So this is the sample input and the output. Now for solving this question, what we need to do is we need to check if there is a player 1 here or here. We need to check for the row, for the column and for the diagonal, is that player winner or not. If in the row all the elements are 1 1, this means this is 3 cross 1, the sum of this is 3 cross 1, which is equal to n, and this means first player is win the match. Now if there is 2 2 2 instead of 1 1 1, there is 2 2 and the second the second player move here, so here second player wins, where this is 3 cross 2, which is equal to 2 into n, that is the second player wins. And let's say if there is 1 and 1 in the diagonal, this means in the diagonal 3 cross 1, which is equal to n, first player win. So this is the way of this is the thing we need to check, is the player having same elements in the row or in the column or in the diagonal, or in the column or in the diagonal. If it is true, this means player win the match. So now let's say I am here and here, 1 is here and here, and 2 is here. Now the sum of these are 2, not 3. Again let's say there is 1, so this is 3, which is equal to the n. This means first player wins. But what if 1 is also here and 2 was here? and this is empty, so initially it is 0. So this means if we sum this will be also equal to 3. But here player 1 is not the winner in this row. So this means this case is wrong. For this case, this logic is wrong. So what we need to do is, here we will change the player where first player will be 1 and second player will be -1. Why I am taking -1 or why I am taking value in negative for the players? Let's see the player 1 and we have the player 2. If we sum the values, it will be, they will go like in, this is at 0, minus infinity and infinity. For player 1, if we sum all the rows, for player 1 it will go till n, and for player 2 it will go till 2 cross n. In this part from 0 to n, there is a common part which is n. So at this case our logic, our code will not work. So for that we are going to change the players, where one player will go here, another one player will go in the negative direction, so that they will never meet to each other and our code will work properly. So here let's say the player 1 is 1 and player 2 is -1. So if we sum all the players, it will go till n, and here for the second player it will go till -n. Now if we change the values of 2, this is -1 and this is -1 and this is -1, this will be equal to -n, and this is equal to n. So this one is for player 1, this one is this -1 is player 2. So when the sum of the player in row or column or the diagonal, if they are equal to n or -n, if they are equal to n, we will return that player, or if they are equal to -n, we will return that player at that position. So we need to map our player, the second player, to -1. Now let's say there is a player here 1. So for this, it also need to check for column, row, diagonal, anti-diagonal, diagonally. So it will take for this of n time, for this also n time, for this also column, and for anti-diagonal. So it will take of n time to check whether the player is a winner or not. So for saving that, for reducing the time complexity, what we will do, we will save the states of the player. Here let's say the player is at here 1. If we save the sum of these in rows, for this it is 1, there is -1. So for this is saved as -1, and here again it is 1, that is the sum is 2. Here -1, again 1, in row this is 3. So this is equal to 3. At this time, at this moment, 1 wins the match. But this is for only the row. We have to save for the column also. So we will save the sum for the column and also for the diagonals. This is for the diagonal, this is for the anti-diagonal. Now here we will save at 0 0. So 0th row add 1, 0th column add 1. Here -1. 1th row -1, add -1, in the second column add -1. And in the diagonal, when we need to update the diagonals, here we can see when R and C, when R and C are equal, R is equal to C, we need to update the diagonals. So here it will be added in the diagonal. And what about this? So this is anti-diagonal, and we do know that when R plus C is equal to n minus 1 is equal to n minus 1, this means we are in the anti-diagonal position. Here we can see if we are here, this is the anti-diagonal position. Why? If we add row that is 0 plus the column that is 2, it is equal to the n minus 1. N is 3 minus 1, that is 2. In this we can also see 1 plus 1, which is equal to n minus 2. n minus 1, where 1 plus 1, that is 2. So this condition true, and this means this is also a part of anti-diagonal. At this position 2 plus 0, which is equal to 2. So for this we need to check when R plus is equal to n minus 1, then we will update the value of anti-diagonal. For this, when R is equal to C, we will update the anti-diagonal. And for these we will update the values in the rows, in the columns. This is for the row, this is for the column. At each time the player moves, at any moment when the player 1 or 2, the sum of the players is equal to n or minus n, this means that player wins the match. So we will return from there as 1 or minus 1 the current player. And if there is no player wins, we will return 0. So this is the explanation. Let's code this. So here we have given row, column and player. Now what we need is int n, then the array row for saving the row sum and for the column sum, then a diagonal is equal to 0 and a anti-diagonal is equal to 0. These 4 things we will use to check the sum if they are equal to n or minus n. First we need to initialize this dot n is equal to n, then row is equal to new int of size n and column is equal to new int of size n. So we have the array. Now here we have taken row and column, and this is also row and column, so let's rename it by RC. Now first we need to I'm going to take a temporary player, which is first player. Now we need to change our player 2 to minus 1. If the player is equal to 2, the temporary player will be minus 1. If the first player, the move is of first player, the TP is 1. If it is 2, then TP is minus 1. Now we will add row at R is equal to plus is equal to temporary player. Now here we will check if row at R is equal to n or row at R is equal to minus n. This means that player wins the match, so we will return the player. If it is equal to n, if we add 1 in the row, there will be no condition comes. Here if there are 1, then it will become 2, 3. If there is any minus 1, this will be equal to 2, which will not be equal to 3. Same in minus 1, if it is 1, this will be equal to minus 1, not minus 3. So for that we are checking if row at R is equal to n and row at R is equal to minus n. We will return that player. Same for the column at C plus is equal to TP, temporary player. If call at C is equal to n or call at C is equal to minus n. We will return that player. We will return that player from there. Now at the for the diagonals, these are for the rows, these are for the columns. For the diagonals, for the diagonal when r is equal to c, when r is equal to c, if r is equal to c, we are adding the values in diagonal of temporary player. If the diagonal is equal to n, or the diagonal, these diagonals are diagonal sum, now minus 1, then return player. Now one more condition for anti-diagonal. For anti-diagonal, when r plus is equal to n minus 1. Here, if r plus c is equal to n minus 1, we will add the value in anti-diagonal plus is equal to temporary player. Plus equal to temporary player. Now, again we will check for the anti-diagonal. If it is equal to n, or it is equal to minus n, we will return the player. Now these are the conditions for the rows, columns, diagonally or anti-diagonally. If all the conditions false, this means we need to return 0. So these are the code. We have initialized the row and column. We have diagonal sum, anti-diagonal sum. This row array and column array saves the row sum and the column sum. If there any moment comes when row sum is equal to n or minus 1, or column sum at c is equal to n or minus n, we will return that player because that player wins. Same for the diagonal and the anti-diagonal. So let's try to run this. Let's try to submit this. So all the test cases are passed, and hope you understand the approach and the code. We'll see you in the next video. Thank you.